right, hopefully we have everybody on board now. So let's get started. Hello everyone, thanks for coming. I'm Doug Smythe from Industrial Light and Magic, and I'm here today to discuss some of the many additions and improvements that have been made to MaterialX over the past year. And I'll also give you a brief preview of some current and future developments. In the chat, we have Jonathan Stone from Lucasfilm's Advanced Development Group, and he can answer questions as they come up, and we'll both be available afterwards for general Q&A. So for those of you who are not as familiar with MaterialX, here's a brief overview. It's a schema and file format that can be used to describe complete CG object looks. Using MaterialX, you can describe your shading networks, your materials, your rendering assignments, and hopefully everything you need to fully describe the look of a CG asset in an application-independent, portable, open-source format. The specification also defines exact behavior for a large number of standard nodes for things like reading textures, procedural pattern generation, various mathematical and image processing operations, various commonly used BSDF shading operations, and nodes to blend and layer them all together in an energy-conserving way. This provides consistent, predictable results when evaluating shading networks, regardless of the application. Some key features of MaterialX include strong data typing, full color management, and compatibility with other open standards. But most importantly, it's very extensible with support for user-defined nodes, shaders, and data types, as well as application-specific attributes and parameters. The bulk of MaterialX is based on the idea of graphs of nodes with encapsulation. Rendering materials are associated with geometries in a look as seen in the upper right, and the materials reference one or more shaders or surfaces or other types of shaders whose inputs can in turn be connected to graphs of pattern nodes. But the nodes within a node graph can also be implemented as a graph of nodes, and even the shaders themselves can be expressed as a graph of BSDF and other nodes. The parameter interface for every node, regardless of type, is defined using what we call a node def, and the MaterialX specification provides definitions and implementations for a large set of pattern and BSDF nodes. So for the rest of the talk, I'm just going to assume that everyone is familiar with MaterialX and its nodes, library, and viewer, and focus on what's changed over the past year. To catch up on all things MaterialX, including current specification PDFs, developer links, and a developer guide and a link to our GitHub, please go to materialx.org. So in this talk, I'll go over new developments in 5 specific areas of MaterialX. Updates to the specification, where the standard nodes and structural elements that make up MaterialX are defined. Updates to the shader generation module. Updates to the standalone viewer for MaterialX content, MaterialX View. Updates to the open source MaterialX library and its API. And improvements to the build environment to support more development platforms. I'll also note some newly added and upcoming support for MaterialX content and digital content creation applications. The first big update to the specification since last year is support for units. The values for floating point and vector inputs may optionally be defined in terms of a specific unit and unit type, which allows applications to automatically convert values from their specified unit into a scene unit specified by the application. This way, images and the quantities they represent, such as displacement amount or the size of an image tile, can be specified in an absolute real-world size and be converted automatically to the expected scene units of the application. Node definitions can also declare what unit an implementation expects values to be in, such as radians for trigonometric math functions. In MaterialX, a single node class is allowed to have multiple node def signatures, i.e. to support different combinations of value types for the inputs and outputs, like float versus color. We found that there are a number of situations where it could be impossible to resolve exactly which node def signature to apply when some inputs were unconnected and left at default values. So these have been corrected by creating new nodes so that all variants of a node have exactly the same input and parameter names, with only the types of the inputs and the output varying from one node def to another. So these are the nodes that have been affected by this change. We also introduced a complete set of value comparison nodes, so any desired value test is now possible. Of course, we're continuing to work on new ideas for the next version of MaterialX, and I'll get to that in a little bit. Excuse me. A large part of the work done in the past year has been in improving the quality of the shading in our Shader Gen node implementations, particularly for GLSL as seen in MaterialX View. One big example of this is the addition of energy compensation within certain BSDF nodes. To compensate for energy missing from multiple scattering on rough surfaces, we now use the method from Turkin, which is simple enough to be used both offline and real-time rendering and gives very good results. So here we can see a gold material that was rendered in MaterialX View with energy compensation enabled on the bottom compared to what we had before without energy compensation. Another very big new addition is MDL Shader Generation, joining the existing OSL and GLSL shader generators. This work was a collaboration between NVIDIA and Autodesk and was presented this year at GTC 2020. As you can see in the images, the results are a very, very close match, including the fractal noise pattern on the marble object on the right. We expect this work to be merged into the 1.38 branch of the public material distribution on GitHub soon, like hopefully within the week or so. In the visual effects production world, a wedge is a series of images where one value is gradually changed over a range while all other values are held constant. The MaterialX Viewer has picked up a cool new feature where you can now generate a wedge image of a float shader parameter by hitting W. Images of the object geometry are rendered into an off-screen buffer and saved to disk, and all the shader ball images in the talk today were generated using this new feature. Now, the implementation is currently a little bit primitive since you have to edit a string of what parameter you want to wedge in the viewer source code and then recompile, but it should be possible to add a more friendly user interface for the feature at some point. There's also now a slider that you can use to rotate the lighting environment. I don't know if you can see it in there. It's the red box in there in the advanced options. But it's really handy if you want to see like how highlights move over a surface material or to align the environment of the MaterialX View with any other reference renders you might have. And then we also added a few more command line options and hotkeys to make using the program a little bit easier. A recently added feature is the ability to take arbitrary MaterialX pattern graphs and bake them down to a single texture per shader input, including proper processing of multiple UDIMs. Under the hood, it's using the existing Shader Gen GLSL code generator to build a shader, execute that shader code, and write out a texture image. You can do this in MaterialX View or from a Python script, and there's a sample Python texture baking script provided to show how to use the new Texture Baker class. Since last SIGGRAPH, the MaterialX codebase has been updated to fully implement the changes and features of the 1.37 Rev 2 specification that was released in January 2020, and its built-in document version upgrade capability has been updated as well. There's a few new utility methods in the API to support new element types like geomprops and backdrop elements, as well as a standard platform-independent method to obtain the default search path for documents. We also changed the internal representation of matrix types so that they're consistent with the representation used in IMath, USD, and other commonly used libraries. For MaterialX builds, we now support the use of VS 2019, Clang 9, and GCC 10, and we're working on adding support for GitHub Actions to provide continuous integration and cloud testing. In April of this year, the Substance team at Adobe released a beta version of the MaterialX plugin for Substance Designer 2020.1. With this plugin, you can create shader graphs in Substance Designer, and then view the graph in either OpenGL or Iray in the Substance Viewer, see your material directly in MaterialX View, or export it into other MaterialX compatible applications. There's also work being done in Autodesk's 3ds Max team to add material support there. Excuse me. It's currently at the level of what they would call a technology demo. And even though they're issuing the standard, we make no promises and there's no delivery date disclaimer at this time, they do have imported MaterialX content working in the Max viewport. And even at this stage, it's starting to look really, really cool. Autodesk has also continued to work on the lookdev editor for Maya, which it showed a preview of at last year's SIGGRAPH. I don't know if there's anything said about a release date or anything for the product, but they are coming along very, very nicely, and we'll see more on that soon, I'm sure. Other things that are currently in the works include adding support for displacement shaders in the OSL Shader Gen code generator, improvements to how documents and their include files are imported. Oh, I love this one. A new shader generator backend for SpearView, which will enable the generation of HLSL, MetalSL, and WebGL shaders, and JavaScript bindings for the MaterialX API. Yay. Again, I'll add that this the little disclaimer that this is work in progress in various forks of the code base, and we don't have an official time frame for this to be merged in to the mainline, but this is all cool enough stuff that I thought you guys would all be interested in hearing about it. As I mentioned earlier, we are continuing to work on improving MaterialX. To that end, we are releasing a draft 1 version of the 1.38 specification next week at SIGGRAPH. And here's a little sneak peek at some of the upcoming enhancements that will be added. The big one is material nodes. These are regular nodes with material output types. This replaces the old material element and shader refs and bind inputs. And all those things should be much, much nicer to work with, and I think that you will all really like it. We're also adding a formalized target definition element, which will support inheritance. Some new standard nodes, because who doesn't like new nodes to play with? Some new mechanisms for node documentation and node organization. And we're also taking the opportunity to clean up some annoying legacy things that made support in MaterialX in applications a little bit more difficult than it should be, and a whole lot more. So that's a brief overview of what's coming in 1.38. We'll be talking about all of these changes and more at SIGGRAPH at our Birds of a Feather session, which is on Tuesday, August 25th at 10 a.m. We have a bunch of great speakers and presentations and demos and all that lined up. And we'll be going into a lot more detail on everything I talked about today, as well as show and discuss other new and future developments. So if you're registered for SIGGRAPH, I hope that you'll be able to join us. Also at SIGGRAPH, Jonathan Stone from Lucasfilm and Nicholas Harrison from Autodesk will be discussing the MaterialX physically based shading nodes in great detail at the physically based shading course on Wednesday morning, the 26th. So that's it for my talk. Thanks to all of you for logging in and watching. And I'd especially like to thank the Academy Software Foundation for organizing and sponsoring Open Source Days and for inviting me here to speak with you all today. So with that, we'll open it up to questions and go from there. Thanks, everyone. All right, so how do we deal with questions? We enter questions into the chat, I believe. So
I can tackle some of the questions that were just posted and answer them live. And of course, we'll be available after this session as well if you want to ask questions either here or in the ASWF Slack. But let's see, I see a question from Kristen asking, Unreal Engine supports this tech. We're working with Epic to move that forward. There isn't anything yet available in terms of MaterialX import-export for Unreal Engine, but it's something that both we and Epic are very interested in, and it's something we expect to see appear at some point. There's another question here from Ernest Lee. I see, when I looked at MaterialX in May, it seemed to lack a metallic roughness material workflow. There was a Disney material support. What is that? So you can define something like a substance designer metallic roughness BSDF through the core MaterialX physically based shading nodes. We haven't done that exercise inside of the MaterialX code base, but I believe that Adobe has already made some strides in that direction. And I'm not sure if they're yet using BSDF graphs to represent, but they certainly can express materials based on the metalness, roughness workflow in the same fashion that you can express other shading models in MaterialX. We're interested in having the Disney principled model be added as an official graph. So just a little piece of data that describes the connections between the BSDF nodes to create Disney principled inside of the MaterialX code base. It's not something that we've had the chance to do yet, but it should be straightforward to accomplish that with the physically based shading nodes. Similarly, I think if a specific vendor wanted to contribute a metalness roughness graph for their particular shading model, we would definitely be open to taking that as a contribution to the MaterialX code base, so that we probably wouldn't author that ourselves just unilaterally. We'd want that to be something that was contributed by the vendor that supports that particular shading model.
I'd also just point out in the the slides that I showed, one of the wedges was the gold material that had the roughness varying over the surface. I believe that's using the conductor BRDF node internally to give the metallic look. So hopefully that's at least a good starting point. And if not, let us know what you think is missing, and we'll be sure that proper support is added. We want to be able to render whatever it is that you guys need.
Yeah, you could either create such a workflow based on something like the conductor node, or based on the generalized Schlick node, depending on how the underlying implementation is done in the particular shader that you're interested in. In something like Unreal Engine, for example, it would be based on the generalized Schlick BRDF. But we can go into further details on that in the MaterialX discussion forum if you're interested. I see one additional question. This is a really popular one. Can you please talk a bit about USD and MaterialX workflows? So I don't want to steal the thunder of what Pixar plans to present at SIGGRAPH, but there's definitely new developments in that space that Pixar will have a chance to talk about. But I don't want to go into the details of what is being developed just yet, because I'd like to give them a chance to speak to that. Oh, and I see one more. Is there support coming for Vulkan in the future? So SpearV would be potentially a way to integrate Vulkan into the mix. Our viewer is currently not based on Vulkan, but we're very interested in creating a version of that that's Vulkan based in the future. Right now it's based on OpenGL, but the same code generation approach that works for OpenGL or any other shading language would work for SpearV as well. And there's no reason why it couldn't be extended to Vulkan-based rendering engines in the future as well.
Yeah, as far as there's a question, a follow-up about the USD and MaterialX workflow, that we're under the impression Pixar is not having a USD BOF. That I believe is true. I don't want to speak for them or whatever, but for whatever reasons they decided not to hold one. So they will be making whatever announcements they're going to make at whatever time frame they feel is right. I don't think it's that far away, but I certainly don't want to set a time frame for them. But I'm very excited about it as well as you are. Can't wait to hear what they say when they do say something about it.
Absolutely.
All right, we have a few more minutes. Any other questions in the Q&A or the chat?
I think that's it for the questions that I see, at least in the Zoom chat, but feel free to follow up on the ASWF Slack after this presentation, and we can help answer any additional questions.
Yep, we'll keep an eye out for that. And we also do have the official MaterialX discussion group. If you want to open up to a wider audience, that you can join that through materialx.org. And there's lots of ways to get a hold of us and the other developers working on MaterialX.
Thanks so much, everyone.